This is section 9.4. We're writing equations of an ellipse. An ellipse is like a circle, but it's lopsided. It has a few different characteristics. It's a set of all points, x, y, in a plane such that the sum of the distance between P and two fixed points, which are pronounced foci, is a constant. So if we look over here at the picture, we have two focuses called foci. All these points laid out here, you're going to add the distance from this focus out to there, called D1 and D2, and these are all the distances that give you the same result, a constant value. When we look at the real detail about an ellipse, it has a lot of parts to it. It has a focus value, which is the distance of what we call C, the distance to a co-vertex is the distance of B, and the distance all the way out to the vertex is a value of A. So this center point is always going to be halfway, or the midpoint between your two vertices. Your center point is always going to be halfway between your two co-vertices. And your focus point is always a C value away. And there's ways to calculate each one of these. A major axis goes between the vertices. A minor axis goes between the co-vertices. So when we look at these equations, the equation, it will always start with x squared and y squared. For an ellipse, the x squared and y squared will always go in that order. Sometimes it'll have parentheses around it if the center's not at the origin. It always equals 1. The question is, what goes on the top and the bottom? The A value is the distance to the vertice. So in the picture that we have here to our right, the vertices are to the right or to the left. They're with the x value. So we're going to say A squared goes on bottom, and B squared therefore will go on that part. Your major axis is going with the x's, so it's on the x-axis, which is called y equals 0. The vertices are plus or minus A comma 0. And the co-vertices are 0 comma plus or minus B. Now, if you look at your ellipse could curve up and down. You still have an A value to get to your vertex, a B value to get to your co-vertex, a C value to get to your focus. It's just that your A value is following the y-axis. So if it follows the y-axis, we still have an x squared and a y squared equals 1. But if the major axis is following the y-axis, the a squared is underneath the y, and the b squared therefore is underneath the x. Your major axis is following the y-axis, which is called x equals 0. Your vertices now go up and down, so it's 0 comma plus or minus a, and your co-vertices go right and left, so they're plus or minus b. The length of the major axis is always 2a. Since from the center point to the vertex is a, the length of the major axis is a plus a, which is 2a. The length of the minor axis is 2b. The foci lie on the major axis, C units from the center, and this is how we're going to calculate this. It's a squared b squared equals c squared. Now what goes in between here, when we're working with an ellipse, it happens to be a minus, because if you look at this, the foci is less than the distance a away. So that might help remind you that it's a squared minus b squared. To figure out this distance of c, it's less than a. It's not necessarily a b value in there, but it does follow this a squared minus b squared equals c squared. So we'll look at example number 1. This is our graph of our equation. We see that this equals 100. It's not supposed to equal 100. It's supposed to equal 1. So what can we divide by to make that equal 1? But we're going to divide by 100. 25x squared plus 4y squared equals 100. If you divide by 100 each time, we're going to get x squared over 4 plus y squared over 25 equals 1. Now we know our a squared equals 25, so the a value is 5, because that's the larger of the numbers. This is going to follow the y-axis. Our b squared equals 4, so the b value is 2. So I can come on over to my graph. I know my a value was 5. Since the a squared was underneath the y squared, we know that it goes up and down. Our b value is 2, both directions. And that's our ellipse. And we write our equation, x squared over 4 plus y squared over 25 equals 1. The vertices are at 0, comma, plus or minus 5. The co-vertices are at plus or minus 2, comma, 0. And to figure out where the foci would lie, we know that we're going to use the format of a squared minus b squared equals c squared. Our a value was 25. Our b squared value was 4. So 21 equals our c squared. So the square root of 21 is c. So the foci follow the vertices. So they are going to be y values. So it's 0, comma, plus or minus the square root of 21. Here's our equation. It's already equal to 1. So we know that our a squared value is 16. So our a value is 4. Our b squared value is 9. So our b value is 3. Our vertices, if you think about our graph, it's going to go right and left because the a value is underneath the x. So these are going to be plus or minus 4, comma 0. Your co-vertices are going to follow the y, so they're going to be part of the y value, so it's plus or minus 3. And to calculate our foci, we've got to use a squared minus b squared equals c squared. Our a squared was 16, b squared was 9, so we get 7 equals c squared, plus or minus the square root of 7 is the distance for our c's. So the foci are going to follow the vertices, plus or minus the square root of 7, comma 0. So all of these have centers at 0, 0. We go 4 to the right, 4 to the left, 3 up, 3 down to make our ellipse. And we also have the square root of 7, which is more than 2 but less than 3. And our equation is x squared over 16 plus y squared over 9 equals 1. In the picture in example 1, we should have graphed in our foci also. The square root of 21 is a little bit less than 5, but definitely more than 4. Those would be our foci. On the second page of our notes on ellipses, we're going to write an equation of an ellipse that has a vertex at 0, negative 7. So we know our a value is 7, a co-vertice of 4, so we know our b value is 4, and a center at 0, 0. That's important to know. That helped us know that our a value is 7 and our b value is 4. So write the equation. If our vertice is following the y-axis, our a squared is going to go with the y, and our co-vertices follow the x because it's first x comma y. So our final answer would be x squared over 16 plus y squared over 49 equals 1. Write an equation that has a vertex at 7, so the a value is 7. The co-vertex is at 2, and the center again is at 0, 0. X squared our a value is following the x, so we're going to say 7 squared, 2 squared, so x squared over 49 plus y squared over 4 equals 1. Write an equation of an ellipse that has a vertex at 0, 10. So our a value is 10, A focus, this is different, a focus, so a C value that is following that, which is 8, and a center. So what we don't have is the B value. So we know that we have to figure out our B value. A squared minus B squared equals C squared. 10 is our A. Eight is the C. So for us to calculate this out, you could say we minus 100. So we get negative 36. So B squared equals 36. And the B would be 6. We actually just need the B squared. So now we're ready to go. We have our x squared plus our y squared equals 1. We need to determine where the a squared goes. The a is following the y values. The vertex is following the y-axis. So our 10 squared is going to go there. Our 6 squared is going to follow the x-axis. So our final answer is x squared over 36 plus y squared over 100 equals 1. Our last example. Write an equation of ellipse that has a vertex at negative 5. So we have an a value of 5, a focus of 3, which is also following that vertex. That's a requirement. So the c value is 3, and the center is still 0, 0. So we know what the a is, we know what the c is. What we don't know is where the co-vertices are located. How far away is that co-vertice? So to calculate that, we're going to use a squared minus b squared equals c squared. We use this equation for an ellipse. So 25 minus 9, 25 minus b squared equals 9. I'm going to minus the 25 to the other side. We get negative 16. So b squared equals 16. So our b value is 4. And we write our equation as x squared plus y squared equals 1. Now we need to determine where does the a squared go. The a was with the x term, so our 25 is going to go underneath the x's. Our b values are therefore going to go with the y squared.